In class 12th, I will tell you about the force on a current carrying conductor placed in magnetic field. This is a current carrying conductor. That carries a current I. It is placed in uniform magnetic field. This is the magnetic field B. This conductor carries a current, so definitely there is the electrons moving inside. This is the electron. So electron moves in the opposite direction of the current. Or this we can have the charge Q moving in this direction. Let this is placed at an angle theta with the direction of the magnetic field. Let A conductor carrying current I we place in uniform magnetic field B at angle theta. The electrons are current carriers in conductor. So the Lorentz force acts on these electrons. Acts on these moving electrons. So what we have? That is the Lorentz force. This F is equal to Q. This is now your V cross V. Now this velocity V, that will be the drift velocity of the electron. Here V equal to Vd, the drift velocity. Drift velocity of free electron. So this F equal to Q, and this is now your VD cross B. Now this is so much. Now in place of this V, we write down this VD, and let the length of the conductor is L. So drift velocity let charge Q flows through the conductor for time t. Then what we have? The drift velocity. The drift velocity Vt, this is equal to L upon T. L the length of the conductor. L equal to length of conductor. So what we have now from here? Therefore, this F is equal to Q, and in place of this VD, this is now being this, we can write it like this one. This is now this L upon T cross B. So what we have? This Q upon T into L cross B. Now by definition, this Q upon T, this is now current. F equal to I into L cross B, where I equal to Q upon T, the current. So this magnetic field F, the force F is perpendicular to both L and B. Now if we open to this one, then this force will come out to be this F equal to I L B sin theta into n cap. N cap the unit vector. Where n cap unit vector. Now this force F, then if we find the magnitude of this F, then this is now your I L B sin theta into n cap. So this is equal to I L B sin theta. This is the magnitude of this force. So the force F is perpendicular to both L and B. It means that the angle between F and L is equal to 90 degree, angle between F and B, that is also equal to 90 degree. So they are mutually perpendicular. So F, L and B, all are the mutually perpendicular. So now you can have that for theta equal to 0 degree, F equal to I L B sin 0, 0 or 180 degree, then this F equal to 0. So this is the minimum force. Minimum force. It means that when the conductor carrying the current is placed parallel to the magnetic field, then no force acts on it. So this is in this way, that this is now your magnetic field. This is now conductor carrying the current I. Then the angle between them, that will be equal to 0. So what we have here, that this L is parallel to B. This is the condition. This is the condition for theta equal to pi by 2. The F equal to ILB sin pi by 2. So this F equal to ILB. This is the maximum force. Maximum force. So maximum force means what? That this is suppose the magnetic field. This is the magnetic field, and this is the conductor carrying the current I. Then this angle between them, this is now equal to pi by 2. So here this L is perpendicular to B. So these are the situation when the conductor is parallel to the magnetic field or perpendicular to magnetic field. So when the conductor is parallel to magnetic field, the force is 0. This is the minimum force. And when this is the angle of pi by 2, then the force is maximum. That is equal to now this ILB. Now this so much. And you are looking from here that this force depends upon the current, the length, and the magnetic field. Thus force F depends upon what? Now this F is proportional to I, and this F is proportional to what? This L. F is proportional to B, and F is proportional to sin theta. The angle between them, sin of the angle. Larger the current, larger the force. Larger the length of the conductor, larger the force. Larger the magnetic field, larger the force. And the theta is pi by 2, then this force is maximum. So this is what that we have when the current carrying conductor is placed in the magnetic field. A force acts on it which depends upon the strength of the current, the length of the conductor, the magnitude of the magnetic field, and the angle between the conductor and that of the magnetic field. The direction of this force is given by Fleming's right hand rule. You can it can be given by right hand and that by the left hand rule. Now there are two rules of the Fleming to find the direction of the force. So thank you very much.